Now, let's begin by adding some lights to our scene. I already used our previously created lamp, scaled it up, rotate it down, and depending on your scene, feel free to do the same, just to find a relative position where you would like to have your lights. Now, you may take a look at the screen and realize suddenly, oh, there's a lot of space to cover. I would have to manually add this light, let's say, every 100 units or every 500 units to cover my whole scene. You may, by all means, do that. But the issue is these lights we are going to add to our scene there's going to be a lot of them because of the size of the scene I made, and it would take a lot of time for me to just manually place them all. Instead, what we are going to do, we are going to create a function and have a construction script that runs by that function that can place these actors in our scene. So let's do this. Let's first of all create a new actor, and it's going to be just an actor. We will call it BP Light Spanner. Open it, save it just in case. For visual purposes, let's add something here that can act. Let's just add an arrow so we can see at what direction the X is. If you are wondering how it would look in the level, if we just add this here. Going to make default scene root, compile. We're going to have this red arrow that shows where this blueprint is looking, which is going to be useful. We can scale this up so it's easier to see. The actor itself will not matter, as this is just going to be used for construction. So the reason why we created this actor is because if we create it here in the construction script, this will run on every copy of this blueprint. But I just want an actor that will spawn certain amount of light actors, and after that I will just remove this actor, so I cannot do this inside. So what we are going to do is we are going to go to construction script, and some of you may have already tried, but if you go to spawn actor from class, you may be thinking maybe I will just click lamp, blueprint, and for, let's say, get actor transform, attach it here and here. You may be thinking, okay, all I need to do is this. And if I go to my level map and press play, there will be a second light. I will simulate it so I don't have to bulk all that way. Well, you are technically correct. It is spawned. Obviously, we did not tell how to spawn, but there is an issue. I still placed only one actor, and that actor is attached to this actor, so we just did it with an extra step. Now your idea may be, okay, what if we use construction script? This is what it is about. You cannot copy directly spawn actor into construction script. This is for computational reasons, because it can easily break the engine if you create an actor that creates an actor that creates an actor, so it is usually not a good idea. Now, what can we do to make this happen? We cannot use this, and we cannot use this because we don't want it to be in-game, we want it to be before game. And construction script happens before the actor is created. It happens before beginning the game or even doing anything in the gameplay. To do this, we need to create a function. So let's create a function. We will call it spawn actor. I somehow managed to mess it up. And we are going to go to construction script and call spawn actor function. And we will copy this and put it inside our spawn actor function. Well, not here, spawn actor. We're just going to do it like this for now. Compile and go back to the level, and you may see, wait, nothing happens. This is because this function is not something that should be callable by the construction script in the first place. So what we are going to have to do, we're going to click on spawn actor and click on call in editor. This means this now can be called before event begin play during the editor. So we're going to go back, and we have this actor selected, light spawner, and we have now a button called spawn actor. We click on it, we have actors that spawned. This is exactly what we need, and we can just now move this actor, click once again, and spawn again. Now, this is still not exactly what we need, but first of all, let's get value for this rotation and scale. Here we need to make sure we get the right values for the spawn actor. So actor we are trying to spawn. To understand how it works, first let's take a look at this node. This node is called get actor transform. Transform means the rotation, location, and scale of the actor. In this case, the target for this node is self, so it means it is getting these actors. By this I mean this arrow actor we created, and it is getting its values for rotation, location, and scale, and we are putting it into this new node here, which is creating the lamp node with the parameters we sent. So it is essentially copying the exact same values from the actor itself, but this is not always what we need. So in this case particularly, we need to edit its rotation and location. We can keep scale as it is because the default scale for this actor is 5, as we have previously set up here, and the scale for the lamp is 5 as well, so we don't really have to change it, but we could do it from the function here if we want. First of all, let's split StarkBin. The reason why we do it is because we cannot edit all these 9 values at the same time easily. So we split them, and we now have individual parameters that we can attach to each other. We can just put in scale as it is, but we need to modify our location and rotation. So what we can do for rotation, you may want to, oh, okay, I will just add the value I want on top of it, and maybe even just plus, but you may notice this doesn't work with rotation. If you do it with vector, it will work. Now, the reason is because rotation is usually not just a value. So actor's rotation is in degrees and not actually float values usually. So what we need to do instead, we are going to put this here as it is for now, and we will further split StarkBin, and we will split StarkBin here as well. So if you take a look at our rotators, here we have a minus 180 rotation for lamp and 179 well, which is actually just a float error, 180 for our Z. But if we move our actor here and let's say rotate it 90 degrees, now it is 90, 180. So what we want it to be is we want it to be minus 180 always, but we want the axis to be modifiable. So what we are going to do, we are going to keep y as it is. No real reason to change it. And for x, we can just put in the value of minus 180. As for z, we are going to add, and what we are going to add here is, let's take a look. If we were to revert z, this will look up, and we need it to look down. So make it 180. I may have made a mistake, but we will know it soon enough. So let's take a look at it by going to our level. That's for now. And click on this and click on spawn actor. Yes, I have made a mistake. You may notice this is incorrect value. It's 90. The reason is because the default value for this is 90. So I should have calculated the difference in between them instead. And for 180 and 00, 180. So for it to be exact the way I want it to be, I would need to rotate it extra. I need an extra minus 90 degrees. So let's do it minus 180 and see how it works now. Again, this is not correct. We are getting the correct X, but we are not getting the correct rotation here because we are adding the minus 180 on top of what's. Okay, let's try to minus 170. Compile and let's try it now. Let's remove this one and spawn actor. Now it is as it should be. So the issue was we had positive 90 degrees by default on this actor, and we needed the difference between this and this spawned actor to be 270. Now let's go back and let's try to make use of this actor. So if I want all actors to line up with this one, I need the z-axis for this and put it here. Copy paste. And let's try it now. Yes, it is more or less the same. Now, to make sure our other axes are correct as well, we will just copy them and place them until they are on top of each other. And after that, we will just move it around. So now their origin points are the same, and we can now move it and click spawn actor. Now it's just spawns actor and it's full of functional actor that we can use. Now, it is still not exactly what we need. This still means, well, technically a bit easier than dragging the required actor every single time. It still means we need to drag this arrow all around and repeat this process. There's a way to make it even easier. So now that we can spawn this actor anywhere we want, let's put it all the way here as the origin point and modify our blueprint further. You may have noticed we have this transform location node. So if we put in additional value here, let's say this is on y-axis currently. So if you put additional y-axis, like let's say 500 units, and press spawn actor, we spawn it 500 further. Let's say we want to spawn a lamp every 500 units. Now let's take a look at our blueprint here. We have this here that's responsible for our y axis location. And what we want it to, for the first actor being created, be at 500, second one be at 1000, third one at 1500, and so on and so on. That means we need to add 500 to this value each time it repeats, but also we need to add some kind of limit to it because we don't want it to happen infinitely. So what we can do here, we can press N key and click on the blueprint. This will create this node called do N, meaning do certain amount of times, and that certain amount of time is this value over here. We will get this and put into a very start. And this is going to be our counter. What we're going to do is do it, let's say, for now 3 times. And each time we do it, and the integer is going to be obviously 0, 1, 2, 3. The reason why it begins with 0, it's an integer, and integers begin from 0. And we need to make sure we edit this value, right? So we are going to split this struct and we are going to get this value, multiply by 500 and put it here. What's happening now is, depending on which iteration of this process it is, it will take this value, multiply it by 500, and place this actor in the y value of that location. So let's go back to the level and see how it works. Let's remove this lamp first and click spawn actor. Now you may notice this is not working correctly because we don't have this going back to the n. This by itself does not repeat it. You need to have the end of this, just limits how many times this can happen. So what we are going to add, we are going to add a rewrite node here to make it clean. And we are going to put it back here, and we are going to move this to have some semblance of organization, which we can use more of in this project. And now we go back, compile, and let's remove this now and click spawn actor. We have now if you take a look at the location value here, the difference is going to be exactly 500. Now this is exactly what we need. Now we just need to have some kind of calculation on how many of these actors we need. And let's say I'm just going to eyeball it, and let's say I want 15. I can just click 15 here, compile it, save it, just in case save it as well. Spawning multiple actors may crash your PC depending on your logic you have put in and your PC's specs. Spawn actor, and I believe I eyeballed it correctly. Yes, now we have 15 lamps with 1 click. There is some shine going around from the lights we created because of the materials we have, which we will fix all later on. Now, we want this to repeat again, but this time on other walls, and we can just take this actor we have, move it around, and now this time we will put it here, all the way on the left side. Now, When we click this button again, we will have this spawned in this specific line. You may be wondering, okay, why did it spawn this way and not in the same direction as arrow as the previous time? The reason why this happens is because while rotation of this actor in the blueprint we have created, let me control Z this, is from the actor transform, we are forcefully adding transform location in a different axis. We are not really using any directionality on where it should spawn. We could make it happen. We could get the actor's current rotation, get the arrow's rotation, for example, and put it in as a value. But all we are trying to do here is to do them in a straight line. And this green line is y-axis, and blue one is z, and red one is x, and our big red arrow is on the x. So if you want to spawn in the x, all we need to do is really just put it here, compile, and press spawn actor. Now the placement of my arrow is a bit flawed, so let's put it like this. Right again. Let's see if they look okay. They're fine. And now what we can do, we can just move it all the way over there. Now we need to rotate this and make sure, ignore the light fluctuations. This is because of the skylight and exposure settings. And now again, we need it to happen on y-axis, but this time if we do it like this, compile, and click spawn actor, it will be reversed. The reason why this happens because we have a positive value and we went from the positive y-axis to a negative one. My apologies, from a negative one to a positive one, a higher y value. So instead, what you can do is put a minus here, compile, click spawn actor, and now we have lights. Obviously, they're not placed correctly at the moment. Yes, much better. And now we do the exact same thing again. We move it around. The reason why we are rotating this and moving around is because we are getting actual rotation from the rotation of the actor. This way we don't have to re-rotate it every single time. And now we will spawn actor again, and obviously it will be wrong. We need them to be in the x-axis now. So what we are going to do, as before, we are just going to move this from the x-axis, and if we try it again, voila. So by making a construction script once, and I believe I misplaced these lamps slightly, so I will have to manually put them down. Oh no, I did the geometry a bit wrong. It should be fine. We are not striving for perfection here, we are just doing a prototype. And the best part here is of making a construction script just to spawn actors, as we did now, is the spawn actor itself is not necessary to remain in the level. We can now remove it from the level, and we have this all these blueprint actor lights set up. And now we can adjust them. So before we do that, let's select all of them. And I would like to add them all to a folder. called lights. And now we can just go into any blueprint. Sorry, not any blueprint. Click on any lamps blueprint to jump straight into it. And we can now adjust the spotlight. So let's adjust the values. We could make these values editable and do it from the editor, etc. But we can just do it also from that here. So let's do it. Let's see how it looks when we do it this way. Compile. Because we have a lot of vectors, it may take a lot of time to compile. And let's reduce the cone range. I want them to be like spotlights. And make it 30. I want it to be 30 as well. Compile. See how they look now. I would like to rotate this spotlight a bit. So select this spotlight specifically and rotate it. Let's see, the face is here this way, so maybe 70 degrees. Compile. Give it a moment. I don't want. I believe we have an extra light here. Remove it. Just check if they have any other extra lights here. We do. And now we have this light setup. Perhaps even a bit more. 60. These lights now need a bit more radius. So let's make them 35. And as for acceleration, let's make it 35. And inner core can be 2. Oh. It's this one. Source radius can be 25. Compile it, go back. This is not what I want from the cone. Let's go back to maybe in 25 and 2500 should work. And now if you play, they are different colors and they should change colors because this is how we set them up in our previous blueprint. Now let's take a look at our spotlight, and I changed my values for 15 and 15 and 2000 for attenuation. And now we have this result where we have spotlights, these colors. And now what I will try to do is to move them around as they are moving the scene. But before that, I do not like the fact that our material is this color. If we are going to have moving lights around, I would like to have my material a bit darker. And perhaps this is a bit too dark in the first place. Let's make it a bit brighter, but not that bright. So we can see everything, but not have sun blinding our eyes. I don't want shadows from the sun, so let's move it around till we get it to position where we are happy with. Maybe something like this. No. This kind of thing you just tweak around until you get it the way you want. Yeah, this is much better. Now I don't want because we will have a lot of colorful lights. I don't want the colors to clash, so I will make it a darker color. And I put the roughness to 1 because I don't want the material to shine too much. Let's do it a darker color for the. Let's do cyan blue, not cyan, dark blue for the first one. The second color can be much darker. Blue. Perhaps we could do it even darker. Save it and take a look. It's fine. And now press play. Yes, now we have colors that are quite easy to see. And now I want to move them around slightly. So we are going to create a new function for it. And let's do it here with a timeline. So what we are going to do here is we are going to create a timeline. And we are going to add a sequence node here. We'll have a sequence. We're going to do this once. And we are going to add a do once node. Do once. Wait, like, apologies, we don't need do once. We just need timeline. Time. Yeah, my apologies. I am not sure why I had to search for it so long. So let's do it like this, so it's not in the way. We are going to have a timeline. And this timeline, we are going to play it from the start. And we are going to, after it's finished, we are going to add delay of, let's say, 1 second. And we will play it again. Even now, okay, we will do play. So the reason we are going to do this, we are going to add a track, and we are going to add a vector track. Yes. And we are going to get a bit creative with the timeline. So we can we have now Z, X, and Y. And we are going to do something quite a bit different. We are going to create a variable and we are going to randomize these values in the timeline.